Okay, we just did I did post the mark and recapture technique and then using the population with the Lincoln index. And we did the new 2022 test question and I went over um, different protocols that you should do, mainly here on II. Also, ways that number could be affected, and then some downsides to mark and recapture. And again, this is like something that would apply to any mark and recapture. The second and last type of sampling method is using random sampling. And you can use that with any of these following types of tools. We could use a framed quadrat, which is identified in this table I made. You could use a line transect, which you can see right here. Transect, like to cut something. Or a belt transect, also very similar. Both could just be like with a line, or if you're doing it in the water, which will be demonstrated in one of the YouTube videos I'll go over with you. You could use something that's a weighted belt so it doesn't float away. Or a line that has different markings on it, like every certain amount of distance on it. And the two different, so you could use, again, the frame quadrat, the line transect, or the belt transect. And then with those different tools, you could do continuous sampling and maybe just sample down the entire line itself. Or you could do systematic sampling. And in this situation, you are going to be sampling every like certain amount of area. So every different like type of interval. So continuous sampling, you are taking a sample or recording an organism that is on the entire, like near or on the entire line the entire way. And then systematic sampling is you are just recording the organisms that are every marked interval as the line goes on. Okay, and with the belt transect, another thing, you're going to use, again, like you could do a tape measure like you see in this picture, or just like a weighted line or white line or rope, and then you'll also use the quadrat. And we have one of these in class. Okay, so I will go over just the basics with it. So, and then we'll do a little bit of practice and then see it in a video, and then we will practice doing a test question for it. So a framed quadrat, and it's not a quadrant like in math class, it's just a quadrat. And this is one that I have in class, except mine in class doesn't have these individual transected lines that go through it, these grids, but they are helpful in kind of making things more precise. And you can even see in this picture, they are using some sort of tape measure along the side of it. Whoop. Okay, we'll just clear those pictures up. Okay, great. So for our frame quadrat, it can be anywhere from a quarter of a square meter or all the way to 1 square meter. And, you know, like using Google Docs, making that like exponent is never immediately that simple. The one I have in class is half of a square meter. And that is actually important. I know in like one of these questions, this one right here, that you do define the size of the quadrat that you use. You can't get another mark. So yeah, the one I have in class is half. So it's in between these two sizes. But that is an important specification to make. Okay, and then how you do it. So you're going to say you're going to use a framed quadrat, or we can say the line transect or the belt transect, but as we get closer to describing those, they'll become a little bit more obvious. And you're going to randomly, for the random sample, this one is kind of just like you're going to throw it in an area that you want to sample the amount of organisms on, or a specific type of organism on. These are going to be used for organisms that don't move, where your mark and recapture was for organisms that move, and they were also in like a very large area that you really just couldn't count yourself. So this is going to be for organisms that don't move. So maybe barnacles, or you're looking at mussels, or different corals. And then there is a large area that needs to be covered. And so there would be like a lot of human error if you wanted to try and do it yourself. Okay, so you're going to take the quadrat or the frame. And again, you want to define the size. It is randomly placed or tossed into the habitat or the environment that you're trying to sample. The organisms that are in there are obviously identified so that you're only counting the ones that you're concerned with, and then they're counted. You will repeat this many times because you want to get an accurate estimate. Then you're going to take the mean or the average from all the samples that you have. And then once you have that average, and you might say, okay, well, I know that the quadrat I'm using is 1 square meter, but maybe you know that the entire habitat is 50 square meters. Then you're going to take your average, how many you have just in 1 square meter, and you'll multiply it by the entire area itself. So the average is applied to the entire size of the environment. Okay, and then I do have this video.
Out the density of organisms. A quadrat is useful for figuring out the density of
and this is a rocky shore, so we wouldn't see this on our shoreline. Here's your macroalgae, your seaweeds.
Organisms in a certain area. I often use quadrats that
tide.
have strings across them in both directions, and what I use that for is to look at all the points where the strings intersect, and I observe what is under those intersections at each point. So I'm looking at what's under all the points of intersection as like a random way of figuring out what organisms are covering the area. Also typically count all the mobile organisms. That's all the things like snails. Those just get counted.
Okay, and she did mention that she, on her own, is counting just the areas that have the intersection. And that's just a way for her to not have to count every single thing that's inside the quadrat itself, and to keep it consistent, but also random. And she's not, doing any sort of bias, like, well, I'm only going to count the ones that are most prevalent. Some people might say, I'm only going to count the things that happen in the middle 2 sections, or I'm only going to count the organisms that are in each corner. This was her way of just keeping it consistent, but then also random. So yeah, so she said everywhere that it touches, like right here, that's where she was counting. And that's not, you don't need to specify that on your exam, but that's just a way to keep it consistent, and then not so there's a bias, right? Because otherwise you might be more prone to counting what's right here, even though that's not the majority of the quadrat. But some people might just say, I'm going to include what's down here, and then you would include that in your procedures. Or again, I'm only going to count what's in the middle right there, but you're going to do that consistently for every single time that you throw the quadrat. Okay. Going over the line transect and the belt transect. I'll show you the video for that. There is one just with the belt transect for macroinvertebrates, so large invertebrates, which would be like maybe a large sea cucumber or a large sea star, big barnacles, things like that. So things you can see, not microinvertebrates. Microinvertebrates are like your zooplankton. But the one that I'm going to show both of these in is this one right here, how to conduct a coral reef survey. It's pretty interesting, and it's actually very simple, and it's a great video example. Okay, so the line transect is actually just going to use, typically it's just what's going to be appearing on this line that you have there. This is used commonly to identify what's happening on an intertidal region. And so you'll want to go there during low tide, where the conditions aren't going to be as harsh and you're not going to be half in water, half out. You're not going to have waves coming in at you. However, in this picture, you can see that they are also using a quadrat. Down here, same thing. The belt transect, they're also using a quadrat. Those are just literally just example pictures that I posted. A line transect, you're going to be sampling the organisms that are appearing only on the line itself. Those are the only ones you're counting. So nothing that would be around it. That's more of the belt transect. The line transect is literally, so line literally, just what is occurring on the line. The belt transect, same method you're going to be using. You could do a tape measure or you could do a rope, but for a belt transect, you're going to be looking at what's beyond the line, and you'll be using a quadrat. And so you'll be sampling what's occurring along this line. Okay. Back to it. So your line transect. A transect can be a rope or a tape measure. It's going to be placed in a straight line along a desired habitat, so whatever you're sampling. It could also be underwater, and that's when you're going to be like using a weighted one. But your syllabus is saying like more for like an intertidal region. So maybe you want to see the organisms when the tide is out at low tide. Also, we have, speaking of tide, spring tide. The moon was huge last night, so this is going to be where your tidal range is the greatest, and during a new moon or a full moon, and we have a full moon. And then within that, there's two different types you can do. You can do continuous sampling. Any species that's going to be touching the line is recorded along the length of that transect. So just no matter what, every time you see a species along the line, you're going to be recording it. Systematic sampling is you're going to be like, it's doing like regular intervals, like in a system. It's non-continuous. So perhaps you want to be doing like, I'm only going to count organisms that are occurring every half meter. So here would be a half meter. Here's a half meter. Here's a half meter. And so you're only going to look right here, right here, right here, right here, and you'll go along the entire length. That also helps keep it non-biased because again, we're humans, so our eyes are more prone to where it's going to be more populous, or sometimes we see a lot of organisms and we're like, yikes, I don't want to count that. But this way, we don't have any of our own influence. It is wherever the line is going to lay. So continuous sampling, you sample along the entire line, and then the systematic is regular intervals. All right, the belt transect, similar method to the line, except now we're going to be using the frame quadrat as well. So typically this will be done at regular intervals. You could also do continuous sampling, but that's going to get really labor intensive because not only are you counting organisms that are along, not just along the line, but also the boundary outside of the line. That's going to get, if you did continuous and you said, oh, nope, every time, I mean, that is going to get really troublesome. So best to not. Erase that. Okay, yep, so the process is going to be the same. You're going to use a rope or a tape measure. You're going to place it in a straight line, your desired habitat. And then you're going to also be using the framed quadrat, and we'll say what the size is. So anywhere from a quarter of a meter to 1 meter squared. 1 meter squared gets pretty big, so it really depends on the size of your organism because this is to help make sampling less error prone and a little bit easier for whoever is doing the sampling methods. If you have very small organisms and you're putting it in a square meter, that's going to get pretty tall. It's going to get pretty long. So like 2 meters is 6 feet. So it's going to be a lot to count, depending on the organism that you're counting, though. Okay, and then so you're going to use the frame quadrat, and you're going to place it alongside one of the sides of the transect, and you decide that. So you would say, I'm going to do it only on the right side or the left side, because again, like just visually, you might see that there's a lot of organisms on the right side, and so just you're choosing the right side now, but you want to have these decided before you go, and then maintain that consistency. And then species that are found within that quadrat are going to be recorded. And then this also helps with observing how species might zone themselves along your high or low tide mark. For example, you're going to see sea stars. Most of the time. They're going to be like, if they're out of water, you're going to want to throw them back in the water. But you're going to see them either stuck within like a tidal pool somewhere, maybe like somewhere over here. They're going to be in little crevices, or even here you can see some waters pooling. That's where you'll see your sea stars. But so you'll see some zonation. Here's a little tidal pool. Organisms that are soft-bodied, like echinoderms, are going to keep themselves. That's not a video. Echinoderms are going to keep themselves submerged. And then things like a barnacle, where they can retract themselves, are going to be able to keep themselves exposed more. And it just allows for more limitations and also allows them to kind of zone in greater areas. Crabs, snails, things with a shell, a hard shell, that are able to avoid desiccation. Those are going to be able to stay like in your low tide mark. And they're going to like they're able to keep themselves out of the water. Like you might see some hard shells right here. They're not going to die. They can close their shell up. Or even if they're snails, they can move, but that's typically how you'll start to see them. Some seaweeds are only going to be able, just some species are only going to be able to stay underneath the water, so they will always be at like the lower zonation on a rocky shore. Other organisms will be able to keep themselves out of the water as well. But if you're an organism that's able to be in the high tide and the low tide area, like where you're always going to be submerged and then at times you're going to be exposed, that's actually going to be better for your species. However, it's not that common because you're going to have a lot of adaptations to be able to survive in the water and out of water. If you think the tide's changing about every 12 hours, like you're going to be spending some time outside the water. But this is going to be like what it's commonly used for, and this is also what the syllabus is specifying, so that you guys would know how to use these at different zonations. Living outside of the waterline. Living outside of your waterline will require additional adaptations, like I just said, to survive your changing conditions. Water maintains its temperature really well. Back from chapter 1, it has a really high heat capacity, so you're not gonna it's not gonna be fluctuating as much as the air temperature will. If it's really windy, they're not going to be prone to any kind of desiccation from the wind or even freezing from the wind if they're underneath the water. So even if it's super sunny, being underneath the water all the time is going to allow them to survive and not be prone to desiccation or drying out. But not every organism will have the necessary adaptations to survive that. Okay. Just for a straight up frame quadrat random sample, before I do the line transect to the belt transect, just a frame quadrat random sample.